C3H6O and CCl4. Which molecule has more valence electrons? Or are they equal? Or do we even have enough information to figure this out? Well, right off the bat, I can tell you that we definitely have enough information to solve this, so we'll eliminate answer choice D. This is the equation we use to go from molecular formula to the number of valence electrons that molecule has, and although it looks confusing, I promise you it's actually pretty simple. Let's look at CCl4. This equation tells us that for each element, we have to take the quantity or number and multiply it by whichever group that element belongs to on the periodic table. Specifically, we take the number of carbons and multiply it by carbon's group number, and we also take the number of chlorines and multiply it by chlorine's group number. It's clear that there's only one carbon and there's 4 Cl's, but what about the group number of each of these elements? Well, carbon is in group 4 and chlorine is in group 7. And it just so happens that the group to which an element belongs to tells us exactly how many valence electrons that element will have. Therefore, each carbon will have 4 valence electrons and each chlorine will have 7. Each chlorine has 7 valence electrons, so 4 chlorines will contribute 28 valence electrons, and adding it to a single carbon's 4 valence electrons leads to 32 valence electrons for CCl4. CCl4 has 32 valence electrons, but what about C3H6O? Hydrogen is in group 1, carbon's in group 4, oxygen's in group 6, which means each hydrogen has 1 valence electron and each carbon has 4, and oxygen has 6. So if each carbon has 4 valence electrons and we have 3 of them, we have 3 times 4 equals 12 valence electrons contributed by carbon. 6 times 1 for hydrogen and 1 times 6 for oxygen. Add them all together and you get 24 valence electrons total for the entire molecule. That means that B is the correct answer. CCl has more valence electrons, 8 more, than C3H6O.